What up, nerds? Welcome back. Today we're going to be talking about storms. Okay, so this should be coming after the um, weather and meteorology videos. So if you've watched those and you're here, you're in the right spot. If you've not watched those yet, make sure that you are going at least a little bit in sequence. You should have done oceans into um, weather systems and clouds, and then moved into meteorology. And now we're going to do storms. Next, we're going to be doing climate and environment. And then after that, hopefully, we should be moving into astronomy. All right, so let's get started. Okay, so there's a bunch of different types of storms, and this should be no surprise to anybody, but we're going to go ahead and start with what we get most commonly, thunderstorms. So what a thunderstorm technically is, what classifies a thunderstorm? This is a brief, heavy storm that consists of rain, strong winds, lightning, thunder. This is caused by friction in between air and dust and water particles all rubbing together. Causes the thunder, the lightning and the thunder. And then the torrential rain obviously comes from all of the water that is building up in these types of clouds, which, if you'll remember, these are our cumulonimbus clouds. Okay. Okay. So the difference between thunder and lightning, people get this wrong all the time. Thunder is just the sound made by what this says, the thermal expansion of air, whereas lightning is an electric discharge, takes place between two oppositely charged surfaces. So two things. Number one, lightning is technically any shock that happens between two oppositely charged surfaces. So whenever you have static electricity, when you touch your little brother to shock him, that is technically, that little spark that goes between you is technically lightning. It's just a tiny, tiny, tiny form of it. Whereas thunder, okay, is the sound that is made by the air in that area going really, really quickly. Okay, so if we're thinking of a little static shock where you're shocking your brother, sometimes you'll hear a little, like a tiny little click sound, a little sound. That is technically very small thunder. Whereas what we normally hear and we normally see and think of as lightning is the much larger, angrier discharge of electricity between the clouds and the ground below. Okay, and the thermal expansion around this is going to be much more extreme, and so the sound is going to be much louder and more extreme than tiny electric shock between you and your brother. Okay, three conditions are necessary for thunderstorms. Lots of moisture in the lower atmosphere, in the troposphere. Okay, the warm air begins to rise. That means that if warm air rises, it usually takes with it a lot of moisture that can accumulate into clouds. And usually the atmosphere has to be unstable. Okay, now this will happen, if you remember from our last video, when two air fronts are coming together and you're getting a lot of kind of turmoil in between them, or it could happen for a number of other reasons. Okay, but the atmosphere is going to be unstable in these cases. Okay, so the stages of a thunderstorm. There's nothing blocked up here, just letting you know. Okay, three stages. The cumulus stage: warm air rises, carries moisture, you start to see cloud formation. Okay, the mature stage, the precipitation falls rapidly to earth with downdrafts. Okay, so as it is accumulated so much, okay, precipitation starts, rain starts falling as more moisture is actually being pulled up, and then dissipation, the updrafts, which is this stuff. Okay, those start to slow down. The storm has no more energy, and so it just rains itself out until it is done. Okay, now it's unlikely that you or I are ever going to be sitting in the middle of a storm to see all three of these stages, because usually wind and air fronts are taking it somewhere else. Okay, but if you could stay underneath the entire time, this is usually what you would see. You would start to see cloud formation first, then you would see pretty steady rain as it kind of stays in kind of a tandem state, and then it would eventually die out. Okay. Now there are several classifications of thunderstorms. Okay, they're classified according to the mechanism that caused the air to rise. So basically, they are classified by what happens to make the air warm enough to lift up into the atmosphere. One is air mass thunderstorms, unequal heating within one air mass. So that is one, so a single air mass, and not a front, not two air masses colliding, but one. Okay. So sea breeze, orographic lifting. So sea breeze thunderstorm looks like this. Okay. Cooler, heavier air moving inland, forcing the warmer, lighter air upwards. So this is okay. This is a little bit more going to be two air fronts, two air masses interacting, but same idea. And then orographic lifting. Now this is going to be one air mass. This is something that's very interesting. So this is what happens with mountains, and the reason that mountains get so much precipitation is because warm air from the valley below will rise up the mountain as it, like the wind might be pushing it, or it just might be moving itself. The air mass will have to force its way up over the mountain, and as it does, the air up here is going to be cooler naturally, so it's going to naturally cool, and then as it does, it's going to condense and then form clouds, and then you get precipitation on the other side. Now, another type are, instead of air mass storms, are frontal thunderstorms. Okay, so advancing cold fronts and advancing warm fronts, okay, are going to cause thunderstorms as well. Okay, this is because of what we've talked about before, that as warm air gets pushed up over cold air, you're going to see a big accumulation of moisture, and then that can cause cloud formation, which causes thunderstorms, which we see here. This is I love this picture. It's so good. Okay, you can see, if you ever see this huge, massive cloud just rolling in, this is a front. This is a frontal thunderstorm that's happening. It's beautiful. I love that picture. Okay. So if you have an advancing cold front, these are going to be severe thunderstorms. Okay, these form lines of storms along the front. The jet stream above can shear off the top of the cloud, forming an anvil-shaped cloud. So if you've ever seen those, where it's like looks like big puffy cloud, and then right at the top it goes like in one straight line. That is the jet stream. For us, most likely as winter turns into spring. There's a reason that April showers cause Mayflowers or whatever. The reason we get a lot of rain in the spring is because cold air masses are interacting with warm air masses, and you're getting a lot of these cold fronts from the north, and you get a bunch of thunderstorms because of it. Okay, and this is why. This is exactly why. Cold air mass comes in, pushes the warm air up above it, creates this big thunderstorm, cumulonimbus cloud. And then if the jet stream happens to interact with it, it can whoosh, shear off the top, and you get this big, weird, flat top going on with this big puffy bit underneath. Okay. Warm fronts are not as likely to produce a frontal thunderstorm because the rising action is just not as extreme as with a cold front. Cold fronts are going to like actively push air up out of the way, be like, get out of here, my turn. Whereas warm fronts are going to be like almost climbing over the cold front while also pushing it, so you don't see as much of that harsh updraft of air and moisture, so you don't get these extreme storms. Now, a supercell thunderstorm. Now, this happens in extreme cases. This is a self-sustaining, extremely powerful storm that has intense rotating updrafts. Okay, there's all kinds of weird words you have here. You don't need to worry about them. Not important. Okay. But it's with your supercell thunderstorms that you're going to be getting rain and hail. Okay, and I don't remember if I have a slide here, but in case I don't, what hail actually is when rain, like precipitation happens, rain starts to fall, but then it gets picked up by the wind, and so it doesn't actually have a chance to fall, and it gets picked up and lifted so high that it accumulates into these globs in the air, in the wind, and then it freezes. And that's how you get those like big balls of ice. So it's not snow, it hasn't frozen in the cloud and then fallen, okay? And it's not sleet where it freezes on its way down, but it's that it got picked up and accumulated into kind of a globule, and froze, and that's why you get hail of varying sizes. Some are really small. Some of you have ever seen those like grapefruit-sized hail pictures that get like crazy. Okay, that's what that is. So a downburst is a violent, damaging thunderstorm wind. This is a wind concentrated. This is in a local area. Local area. Okay. So this can be that you've got relatively dry air around the sides, and that is lifting up. You're getting an updraft into the cloud, but then there's one spot where it just kind of goes, poof, absolutely blasts down wind with rain as well. Okay. Okay. So I do have a slide for it. Yeah. So hail. Precipitation in the form of balls, lumps of ice, they form in severe storms. This is an indicator of tornadoes because of exactly what I just said. The warm updraft brings, okay, so the cold downdraft brings the precipitation down, but then a warm updraft picks it back up, and the wind is strong enough that it actually lifts it back above this kind of freezing line. And so you get water accumulating and freezing, and then because it's heavier, it won't get picked up again and it falls. And this is what you see here. Look at this softball or baseball sized hail of varying shapes. This stuff is nuts. Hail is what does a lot of damage. You do not want hail hitting your car or your house or anything like that. Okay? Okay. So, if you ever hear a severe thunderstorm warning, it says severe thunderstorm warning, things to keep aware of and things to keep in mind. Thunderstorm with winds of 58 miles per hour or greater is considered a severe thunderstorm. Okay? Could experience penny-sized hail or larger. If it's a severe thunderstorm, it's going to have a lot of lightning. A lot of turmoil, a lot of rubbing up against each other in that cloud, a lot of lightning. Okay, recommendations are stay inside. This is dated. If you have a landline, it says to keep off the phone because there's a possibility that lightning strikes can travel through wires, but that's really not a problem as much anymore. Don't take a shower bath. Same idea. Same idea. If you know that there's a crazy thunderstorm happening, there are some electric plumbing line, or not electric, excuse me. There are some like metal plumbing lines that can conduct electricity, and if it gets hit by a lightning strike, it can travel all the way through. I mean, better safe than sorry, but most things are fine. Stay away from windows. Good idea in any storm, really. Just leave it be. Don't stick by the windows. Don't do the thing that I do and you sit there and you go outside and you watch and you're just like, wow, it's amazing. Okay, so don't do that. Don't do what I do. Tornadoes. Okay, because so tornadoes can sometimes go along with thunderstorms. So check this out. Look at this. So we're going to talk about tornadoes. A tornado is a destructive rotating column of air. And specifically, this is one that is visible to the naked eye. And the reason for that is either because of moisture that is trapped in the column or because of dust or dirt that gets trapped in the column so we can see it. Okay? So tornadoes are classified on what we call the enhanced Fujita scale. And this ranks them according to wind speed, duration, and path of destruction. So we usually talk about it's interesting, we always have like all of these different ranking systems, but so a tornado, if it's a like category 2 tornado, right, that means that top speeds we're seeing 111 to 135 miles per hour, which is very, very fast. Category 5, which are the like crazy tornadoes, are going to be over 200 miles per hour top wind speed. And look at this jump. This is hard to get to. Okay, it's about a 24 mile per hour difference, about a 30 mile per hour difference, almost as a 34, 35 mile per hour difference. So big jumps in between these. If you're over 200 miles per hour, you got to get out of there. Okay, things to be aware of with tornadoes. Okay, if you're hearing a tornado warning, it's because a tornado itself or a funnel cloud has been detected or seen in the area. Your recommendation is to take shelter immediately. Okay, if you are in a house that has a basement, get under something sturdy in the basement. If you don't have a basement, go to a room that has no windows, like a closet, a bathroom, something like that. You do not want, if a window breaks, you don't want shards of glass flying around. If you're in a mobile home, get out of it. go to a storm shelter, go to a local, like a public library or something nearby that you can actually like take shelter in. Worst case scenario, if you're in your car or if you're outside during a tornado, find a ditch, like on the side of the road, find a depression in the ground, get in there and lie as flat as you can. The reason for that is because the winds are going to be whipping around, but if there's a small divot, okay, winds don't usually like duck in under divots and pick stuff up. If you're lying flat, it's going to be really hard for wind to get underneath and lift you up, and it's also going to be less likely for things to fly on top of you. So I'm going to stop this video here, and we're going to continue in the next one. So until next time, stay curious, stay wonderful. Gucci.